Digital Mockup or DMU, Lecture 5. Okay, so let's first talk about what is a mockup. Okay, so let me show you some examples. So here's a concept car this company is working on, and they want to create a mockup of the interior. Here's a better picture of it on the left. So if you want to check for mistakes that you don't want to find at the assembly level, last thing you want is to go out into the assembly facility and you're starting to install the actual seats to the vehicle, and there's some issues with installing, or there's things clashing each other or hitting each other as you're trying to install them and you can't fit them in right. So one of the things you can do is create a physical mock-up out of plywood, foam board, cardboard, or PVC pipes, or anything you can get at a hardware store. Something cheap where you can put it together and it's accurate enough to give a representation of your vehicle in this case. You want to make sure that it's easy to install the seats, easy for the passengers and driver to get in without any issues. You also want to see if you can easily run the electrical in this vehicle, install the dash, steering wheel, etc. Okay, so this is an example of a vehicle. Let's take a look at an aircraft. So here's an actual mock-up made out of wood of this Bombardier aircraft. So the reason for this mock-up is to check and make sure that the installers can easily go into the aircraft and install wiring, electrical, plumbing, interior components, seats. They can that they're not going to have any issues installing the instruments, for example. And you also want enough room to be able to turn a wrench. So when there's installation going on, sometimes you need room to install rivets or bolts and nuts, and you're going to need wrenches. And then sometimes there'll be some tight spaces where you try and get a wrench where you have to tighten a bolt or a nut, for example. Okay, so it's always a good idea to come up with a mock-up and not find issues later on when you're actually doing the actual assembly at the assembly plant. All right, so for our lecture and assignment, we're not going to do an actual physical mock-up. We're going to do a digital mock-up. And we're going to be using either the DMU Navigator workbench or DMU Space Analysis. Here on campus in the computer lab, we have access to both workbenches. Most likely, if you are using a student license like I am, most likely you only have access to one of these two workbenches. All right, so let me go all the way down to the last slide. For your assignment for this lecture, for our digital mock-up assignment, it's going to be worth 100 points. We're going to do three things. First thing we're going to do is redlining. So we're going to do 2D redlining on a 3D CAD model. Okay, so you can see red lines here. So when you submit your work, either your boss, supervisor, the lead engineer, or a checker is going to look at your work and check for mistakes, or maybe ask you to make some changes. Okay, so we're going to first learn how to redline. Then we're going to do section views. So as you see here in orange, this is a section view or a section cut of an assembly, and it's to check to see if any parts are hitting each other. You don't want parts buried into another part. And finally, we're going to do a clash report where we generate a report and see if any items are either touching or buried into each other, clashing. Okay, so let's start with red lines. So let's go to the very beginning. Okay, so DMU Lecture 5. Okay, so you're going to open an assembly. You can use whichever assembly you'd like to use. And we're going to go to Start, Digital Mockup, and go to either DMU Navigator or DMU Space Analysis, and that'll give us access to this toolbar, this DMU toolbar. And we're going to click on the 2D icon, which then will give us access to these commands. And when you're done, just like in Sketcher, you can exit by clicking on this icon. Okay, so let's go into the DMU workbench. Let's see which one we have access to. So open up any assembly. me move this out of the way. I'll just double click and it'll dock it. Okay, so currently I'm in the assembly workbench. So I'm going to go into the DMU. So I have access to the DMU Space Analysis Workbench. Click on it and you'll see my icons change. So currently we are in the DMU Space Analysis. Most likely your toolbar will be here, docked on the side. Okay, so we're looking for this 2D icon. So if you want, you can undock this toolbar, hit the Shift key. For lecture purposes, I like to pull the toolbars out so you can easily see it on the screen here. So here we go. Here's the 2D icon. Click on it, and you'll have access to this toolbar. Okay, so let's say, for example, I wanted let's say I was checking your work, and let's say you use an iron knob here, this threaded knob, which serves as a nut, and you can just hand tighten. So typically you have knobs that work as nuts for speed. So if you're going to be constantly clamping, unclamping, clamping, unclamping, and not have to reach, so that you don't waste time reaching for a wrench, you can use a knob that'll serve as a nut. Okay, so you can order these from McMaster or Carlane. Let me show you the websites. Okay, so I can go to McMaster.com. Okay, McMaster.com has pretty much anything you need. Bolts, nuts, welding equipment, welding gear, piping, etc. So some of you are already familiar with this website. I'll talk more about this in the next lecture. Okay, so I can simply type in knob. And there they are. Here are the knobs. So I typed in search for knob. And right away it took me to a bunch of knobs. And this is the type we're looking for here. The one I downloaded to use for our clamp assembly, I got it from Carlane. So I'm going to go to the Carlane website, carlane.com. And their catalog is not as user-friendly, but let's see. Here we go. We have knobs. Here we go. This is what we're looking for, knobs. If you work in a machine shop or metal forming shop, you'll be ordering a lot of hardware from Carlane and McMaster. Here's the knobs we're looking for. So I just wanted to show you that. Let's say, for example, you chose to use a cast iron knob, and the checker decides, hey, you know what? I'd rather you use aluminum. Okay, so let's say I wanted a red line and tell you to switch over to aluminum. Okay, so when you click on this 2D icon, which we already did, we can tell by this toolbar showing. See, so we're already in a 2D view, so I'm currently redlining. Make sure you first position or orient your assembly before you click on 2D. If you didn't, you can always exit, or you can rotate. I'm going to rotate the assembly, and you're going to see I'm going to exit out of this 2D toolbar. As soon as I rotate, it exits. So currently my view 1, if I was to double click on it, is empty. Okay, but that was the orientation I started in. So let me go ahead and exit. I can exit. I'm going to go ahead and delete this and start from scratch. Delete. Okay, so currently I have no 2D views. So once again, first position, orient your assembly before you redline it. Okay, so let's say I like it right there at that orientation. Okay, now I can click 2D. Now, since it already used view 1 point as instance 1, it's going to go on to view 2. Even though we deleted view 1, it's going to move on to instance 2 and 3 and so on. All right, so let's say I wanted to let you know to change the knob. Okay, so I'm going to use the circle command. Then I'm going to click somewhere in the center, left mouse click and hold, and while you're holding the left mouse button, move your mouse to adjust and define your radius, and there it is. Okay, now I'm going to put an arrow to point to it. So I'll use the arrow command. So I'm going to left mouse click, and hold, and then let go once I've placed the arrowhead. There it is. Okay, so I'm going to type in or write in use aluminum. Now I'm actually having an issue with the text icon here. For some reason it's slowing down my computer. Maybe my computer's too slow to generate 2D and a 2D text and 3D. So I'm going to do it the hard way. I'm going to use the freehand line marker here, or else I would use the text to create text here in space and say use aluminum. But I'll do it the long way. I'll use a marker here. And I'm just going to write in I'm going to left mouse hold, draw my A, click again on the marker, let go of the mouse, of the left mouse click button, let go. Let's do it again. Click on the left mouse button and hold. Here's my U. Let go. And let's do the M. Left mouse, click and hold, and I'll draw my M. Okay, so I'm going to say use aluminum. All right, so other options you have here is to insert a picture. You can insert a picture. You can record a message. You can also delete. So if you want to delete something, so let's say I drew a line by mistake. You can delete the line, or you can delete everything. So unfortunately, when we click the eraser, it'll delete everything. Let me see if I can hit undo. So I hit undo, there it is. I was just trying to simply delete the line, but it looks like maybe if I just click on the line and click delete. So I click the delete button on the keyboard and it deletes it. Unfortunately, the eraser will delete everything. Okay, and you can also leave a recorded message. Okay, once you're done, you can either hit exit or rotate to exit this note. So I can exit. Okay, so that's more than enough to get credit for your notes. If you want to see your notes, double click on the, in this case, view number 2. Double click and it'll take you to that note. If I rotate, it'll exit. Once again, double click on view instance 2 or instance 1 in your case maybe. Okay, and you can exit and you can add more notes. Okay, so let me show a different perspective. Let's see, front view. Okay, so let's say I wanted to do a view here. Okay, once again, you're going to see it'll now create a view instance 3. If I do another, oh, clicked on the wrong thing. Sorry, 2D. So click on 2D. And let's say I wanted you to check the gap. I'm going to use an arrow. And I'm just going to magically write gap with the marker. Again, I'm having issues with the text. My computer's slow. It's freezing up on me anytime I use text. Maybe you're not going to have the same issue. Okay, so if I wanted you to check the gap size, okay, between the two. All right, so I'm just making stuff up as far as things to redline. If you just simply draw a red circle or write in text or an arrow, you'll get your full credit for the red line. And when you're ready to exit, click on exit. So once your boss returns your assembly back to you, saves it and returns it to you, you can check the red marks, the red lines, double click. There's run. Okay, change to aluminum. Go to the next one. And it'll tell you, it'll give you instructions of what to fix. Okay, it would obviously be more detailed, but I just wanted to show you how to use the commands. Okay, rotate to exit. Okay, so that's the first part of your assignment. And once again, if you wanted to do text, click on the letter T. And this is the way it would look. So if you wanted to check a clash, for example, so you click on T for text, type in your text. You can also change the size of your text height. You can either type it in or click on the arrowheads to increase or decrease the text height, and you can add text. Okay. And once you're done redlining, exit. All right, so let's move on to the next topic, which is clash analysis. Okay, we'll do a clash analysis and then we'll do our section cut. Okay, so clash analysis, you can find this icon, the space analysis toolbar. You can find it in the DMU Navigator workbench or DMU space analysis workbench or in the assembly workbench. Okay, so either one will give you access to this icon. Okay, I'm looking for, there it is. There it is, clash. So you're going to look for this icon where you see a sphere hitting a rectangular prism, and there's a collision, and it appears like appears to be an explosion here. All right, so you can either go here, or if you don't have access to this toolbar, you can always go to Assembly Design. Go to Assembly Design. Okay, so go to Assembly Design, and you also have access to the, let's see if I can find it here. Oh, actually, here it is. Here's the toolbar I was looking for. Let me double click to dock these toolbars back in place. Okay, so this is the space analysis toolbar. Okay, so we're going to do a clash. We're going to check to see if there's any things hitting each other or parts buried in each other. Again, as I mentioned in the past, or in a few slides ago, we always ran a clash analysis on the vehicle we were working on to make sure there was nothing hitting each other, any components hitting each other, whether it was interior hitting structural components or electrical running through walls, structural walls, for example. So we always had to do a clash analysis, especially when you have thousands of components. Okay, so we're going to click on the clash icon. Let's go back to the lecture. Click on clash. And we can do typically you want to do a clash analysis between all components. No matter which assembly or subassembly they're in, you want to check every component to each other. So we want to check that the knob doesn't clash with the washer, with the hook, with the strap, with the hex nut. So it'll check with every single component, and vice versa. The clamp strap will also check to see if it'll clash with any of the hardware. Okay, and then we'll hit apply, and it'll generate a report. It'll generate a report, as you can see here, of all the issues, anything clashing. So here it's telling us there's 9 issues. And then you can save it by clicking on this icon. It'll save it as an XML document. Okay, so let's go ahead and do our clash analysis. Go back to CATIA. All right, so let's go ahead and do a clash. Click on clash. Okay, and we're going to say, hey, we want to check contact and any clashing between the solids or the components. And we want to do it between all components. You can either do a selection, or in this case, we're going to just do all components. Let's do a clash analysis between all components. Not only clash analysis, but contact. Okay, and then we're going to hit apply. Okay, so let's take a look at the first one. Move this over. I can increase this window in size. Okay, so here's the first issue. It's telling us, hey, there's an issue between the clamp strap and this jam nut. Okay, so let me go ahead and increase these columns. Okay, so our first issue here is clamp strap and jam nut. I can zoom into this window. It's like, hey, so what's going on? and it's just making contact. It's not buried, so this is not an issue. So here it's telling us what type of issue do we have. Oh, it's just a contact. The hex nut is touching the clamp strap. They're not buried into each other. It's just a contact, face-to-face contact. So we're going to click here and go, you know what, notice how there's a red light. It's going to turn in color when I say, you know what, I'm going to click on this where it says relevant and say this issue is irrelevant. Notice how it changes in color. Okay, now we can go on to the next issue. Hey, there's an issue between the swivel foot, the threaded shaft, and the hole. Well, obviously this counterbore hole is supposed to be a tapped hole. We don't model threads, by the way. So this is a tapped hole, and it engages with this threaded shaft, right? And we can have a tool here to turn it. All right, so we don't have an issue with this, so we can go to that second issue here, clamp strap, and this is a CL. This is a Carlane-30-SSC part, which I got from Carlane. So I downloaded this model from Carlane, and I can say, hey, yeah, there's a clash, and there's telling us a value. Hey, there's a clash of up to 15.652 in millimeters. So it's telling us there's a clash of up to 15.652 millimeters, but it's just threads engaging with threads, right? So we're going to say irrelevant. So where it says relevant, click on it, and it's irrelevant, and it turned to yellow. And move on to the next issue, issue number 3. So here we have a sleeve or a plain bushing, which slides into this counterbore hole, and it's making contact, right? So it's making face-to-face contact, and that's not an issue. So we can just go to the third issue and say irrelevant. Okay, move on to item 4. Let's take a look at the next issue. Hey, this washer is making contact. So it's just making contact, face-to-face contact between these two items. So we can go ahead and say, hey, yeah, we see the red light over here on the left. Click, make it irrelevant. No issue, not a problem. Let's go on to the next issue. Hey, there's an issue between this threaded shaft for the swivel foot and this hex nut. Obviously, they're going to engage. The threads are going to engage. Not an issue. Irrelevant. Move on to the next one. Hey, this long bolt is making contact with this counterbore hole. Okay, so the bottom of the head of this green long bolt is making contact with the bottom of the counterbore hole. It's not an issue, so irrelevant. Move on to the next issue. So here we have a threaded or a tapped hole, and again, we don't model threads. That eats up a lot of memory. And this little swivel pad, you can see it has a threaded shaft, and the threads engage, and you turn it with the wrench to tighten it in place. Okay, so that's not an issue. Irrelevant. Irrelevant, there it is. Go to issue 8. And again, the sleeve or bushing is making contact with the shaft of this hook. It's just face-to-face contact. It's not an issue. And we can just say irrelevant. And let's move on to number 9. Here we have that aluminum knob that we ordered from Carlane. Okay, and it's making contact with the threads of the bolt, which is not an issue. It just happens that the hole does have threads. That's the way I downloaded the model from Carlane. Okay, so we'll say irrelevant, not an issue, and move on to the last one. And we have contact between the washer and the knob, and that's not an issue. Okay, so we can say irrelevant. All right, so let's go back to, we're not going to hit OK yet. Let's go back to the lecture notes. Okay, so what we're going to do is we're going to click on this icon here that looks like a little manila folder, and we're going to save our file, our report, save it as an XML document. And we also have other options as far as extensions of how to save it as. Okay, so let's go ahead and save our work. So we're going to generate a report, and we're going to export it. So click on this little manila folder, click on it. Okay, say OK. Now it should save it. Oh, it's not saving it in my clamp assembly folder. So let me, maybe that's the reason I got that little window message. I'm going to place it in my CAD32 folder, assignments, top clamp assembly. There's my folder. And you can see some previously federated Clash published folders. So it's going to generate a folder like the ones you see here. Some of them I generated. One of them I generated back in 2017. Okay, another one I recently generated this Clash report. I'm going to generate a new one, and you can see it's going to save it as a folder federated _ Clash published on this date, the day, month, year, and the time. So this is the time, the date and time that it was generated. You can save it as an XML, a text, model, or CGR. We're going to save it as an XML file. Okay, so I'm going to save it, and it'll create that new folder, federated Clash publish, today's date and time. Okay, so I'm going to click save and give it a few seconds for it to save that report. Now, you may have an issue with this. As it's generating the report and saving it, it should then open it up as an XML web file. And as you can see, there it is. Depending on what you're using, whether it's Chrome, Internet Explorer, it may not work for you. So if you don't get to this point and it doesn't generate a web page like it's generating for me, it's not a problem. Let's go through this report here. So here's the XML file. It's giving me a list of all the components in the clamp assembly, and it's giving me a report for each issue. Okay, so if I want to see what's going on between the hex nut and the clamp strap, I just click on this link, and it'll give me a little summary of what's going on. Hey, we have an issue between the hex nut and the clamp strap, and it's just a contact, and it's 0 millimeters as far as the clash. It's just making contact, so it's 0 millimeters, and it's irrelevant. Okay, we can go back and go on to the next issue and so on, right? So now we're looking at an issue between. So this is something that you can show in a meeting. So once a week, you'll meet with other departments and discuss the issues. Hey, we're having an issue with your part clashing with my part. How are we going to solve this? Typically, you try and get the other person to make the change. And there's always a lot of finger pointing. Hey, no, you fix your part. No, you fix yours. No, you got to change yours. And you have to compromise and come to a decision as a department or as a company as to who's going to fix what and who's responsible for it. Okay, so let's go back. Okay, so this is the XML file, and that's another portion of the assignment. If you were not able to view your XML file, it's okay, don't worry. I'm going to go ahead and close it. I'm going to go to that folder where I saved it. So even if you have issues generating that file, it's okay, because you're going to send me that folder, that federate, I think it was federate or federation folder. Let's go back, take a look at it. Assignments and top clamp assembly. Okay, so you're going to send me that federated Clash publish folder. If you want to zip it, I think you should zip it before you email it to me. So if I double click on it, there's going to be all these folders. So in here, you're going to see what generates that XML file. Okay, so here's the XML file, and all these are the components that are part of this XML file. If you go into pictures, double click to that pictures folder, you're going to see all the pictures that are part of that XML file. Let me go to view and show as icons. And you can see the pictures that we saw in that XML report of showing all the clashes or contacts. Okay, let me go back on the folder. And you should be able to double click on this XML file. I'm going to double click and you should be able to open it as a web page. If you're not able to, it's okay. You'll still get full credit. Okay, I don't want you to get frustrated if you cannot open up this XML file. Okay, I'm going to stop there and we'll move on to the next topic. Okay, so I'm just going to hit OK. Okay, there it is. And let's move to the final topic. All right, so once again, it'll generate an XML document. Okay, next thing we're going to do is a section cut. Okay, so this is a very common command used in, especially in automotive, when you want to check that parts are not clashing with each other. And let me show you a good example. So one of the issues that I got to work on this vehicle. So here we have this luxury car, and you can order it with whatever fabric you want or leathers. It's an expensive luxury vehicle. One of the issues we were having with this model, the first model that came out, was this A-pillar. So this is a plastic cover or plastic component, and it's covered in fabric. You can also choose to use leather if you like. One of the issues we were having was that there was not a smooth transition between the headliner and the A-pillar A-pillar. You should have a nice smooth transition. One of the problems was that this would stick downward too much, that you can actually stick your fingers inside this A-pillar plastic. And just to show you, this is a very expensive vehicle. And last thing you want is to have an expensive vehicle where the things are not flush or they don't line up with each other, especially if you're paying over $100,000 for this vehicle. Okay, so the issue we were having with, and let me show you the component online. So here it is without the fabric. So luckily found a picture here. All right, so one of the issues we're having with this is, so this is the top portion. This is the lower portion. I may have it backwards. Actually, this looks like the lower portion. Well, the issues we were having was these plastic towers. So these are referred to as towers. And you can just buy these clips from a catalog. And this is to clip onto the structural member of the A-pillar of the vehicle. So the issue we're having is that these towers were just way too tall, and it was causing the A-pillar plastic piece to stick outward. So I was asked to shorten these pillars for the next model that was going to come out. We're going to leave everything the same except just take these towers, make them shorter, and reattach the clips, right? So we would have to alter the tooling for this piece and to get a better fit and finish on our vehicle. Okay, so the thing we had to do was do a section cut first in our meeting. Before I started making any changes, I had to sit in a meeting and we had to discuss the issue. Okay, so up here on the A-pillar where it attached to the headliner, we had to do a section cut in the actual 3D model. And again, these models were just so huge as far as file size that it would just slow down your computer. And we would have to go into cache mode, something I discussed in a previous lecture, but I'll talk about it on our last lecture of this class. We're going to talk about cache mode, where you open your CAD models as a shell, non-smart. Think of it as dormant. Think of it as your CATIA files as dormant, and you can always double click on the file you want to work on, and it eats up less memory. Let me get a better picture of that A-pillar. Here it is. Here's a better picture. Okay, so in the 3D model, we were taking a section cut here, and here you can see it's actually a lot obvious here that this is not a good fit and finish here on this seam here between the A-pillar cover and the headliner. Okay, so we can take a section cut and see here, you can actually see you can stick your fingers in here, which that does not look good. Okay, so do a section cut in 3D. So that's what we're going to do with the clamp assembly. So we're going to do a section cut to check for any issues. All right, so let me go ahead and close the internet here. All right, so we're going to do a section. So here's the icon, sectioning. Click on it, and it's going to bring up a window. I misclicked. Let me click on it again one more time. Click. Okay, I misclicked the first time. And it'll give us a second window so we can see the actual cut. There it is. I'm going to go window vertical so I can see both windows. Okay, so it's taking a cut and it's only doing a partial cut. It's showing the knob and it's showing the washer. Let me change the positioning. I'm going to go to the positioning tab. Right now it's cutting normal to the x-axis with respect to the compass. So here's the compass. It's cutting with respect to the x-axis. Let's go to the y, see what it gives us. Same result. And the z. Okay, so here it's cutting in the z direction with respect to the compass. Let me move my file a little bit away from the compass. So right now my section cut is normal to the z-axis. And we can actually click inside the yellow area and we can move this up or down and look to your left. Okay, let me cut through the X. That's the one I want. Now, it should have given me a section cut of the entire thing. Actually, it's not giving me what I want. And I think it's because my computer is slow. Let me cancel and try it one more time. I'm going to cancel and do the section cut one more time. Section cut. Yeah, I'm having an issue with my computer. It's just too slow. So go window vertical. Okay, so it should show me a cut of the entire thing. It should show the clamp strap and all the other hardware. Let me show you what it should look like. Okay, let's go back to the notes. So it should have done a full extended cut and shown all the components. Cutting through everything. And it's just a good, easy way to check for issues. You do a section cut. Sometimes it's hard to visualize this when you're cutting through a 3D model. But you can look at section cuts to look for any issues, to see if anything's clashing or anything's buried. Okay, let me go on to the next one, the next slide. Okay, I'll come back to this one. So let me go back to the previous slide. So once again, you can click on Y to change the orientation of the section cutting plane. It'll go normal to whatever axis you choose. Here's the Z, the Y, and so on. And if you go to result, it'll give you a solid result versus a wireframe. Okay, so let me show you that in CATIA. So here's that option here. If you don't want to see wireframe, so currently I see wireframe. If I want to see a solid, I click on this option, volume cut. And if I want to see it on the left, I'll go to Result tab. Oh, my mistake. No, it's actually, it is in the definition. My mistake is in the definition. So here's taking the cut, but it's not showing it here on the left. Let me check this. It'll turn it back to solid. There's the section cut. So here's what I'm looking for. I was hoping it would also show it here on the left, But again, my computer's giving me issues. All right, so let's go ahead and finish this lecture. All right, so if you want to save that section cut, it'll save it as a wireframe. You can click here on this option. It'll save it for you as a wireframe. It'll be non-smart wireframe, which then you can call up. And this is the file that I'm going to save and insert it into the top clamp assembly. So you can see it here, and it'll show us the wireframe. All right, so let's go ahead and do that step. Okay, so we're going to go ahead and save the result. Again, it's incomplete, but let's go ahead and save it just so I can walk you through it. Go to result, and we're going to go ahead and save it, export as, and we're going to save it as a cat part. Okay, so I already have a section with that name. You can leave it as section 1. I already have previous section cuts that I've done in the past for previous classes. I'll just call it section 2020. I'm going to save it. Okay, and I'm going to hit OK. I'm going to go ahead and close this wireframe window, close it. And I'm going to double click on the blue frame, or you can hit max to increase the window size. All right, so the next step I'm going to do is bring in that section. All right, so I'm going to go to my folder. Where I saved that section. I'm going to go ahead and open it. Here's my section 2020. Hit open, and it should bring me the wireframe. Okay, there's the wireframe of the knob and the washer. I was supposed to get an entire complete wireframe of the assembly. All right, so I'm going to go ahead and close this one. And I'm going to open up one of my old sections that I did for a previous class. Okay, so I'm going to go to File, Open. Let's see, section 1. Yeah, section 1 looks like a good one. Let me go ahead and open that one up. This is one of my old ones. Okay, so this is the result I was looking for in this lecture. Okay, so here's my wireframe. It's hard to see, it's thin. One thing you can do is, let's see if I can thicken the wireframe just for this lecture so I can see it better. Right-click, Properties. Let me see if I can thicken it here in the Graphics tab. And I'm going to go to Lines. Let me thicken it up to 4. Apply. It didn't do it at the geoset level, geometric set level. Okay. No, I didn't do it as a group, so let me do it individually. So I'm just going to click, hold on to the Shift key, select all of them, right-click, Properties, and I'm going to do the exact same thing. I'm going to make the lines thicker. Go to Lines and Curves. I'll make it 4 times or 1 millimeter thick. Apply. There it is. And OK. Okay, so I can see them a lot better now with the higher line type, or I should say line weight, thicker lines. Okay, so now I'm going to go ahead and right-click, copy, and I'm going to paste it onto my assembly. Copy it. Go to my top clamp assembly. And I'm just going to go ahead and paste it just to visually show you what we just did. So I'm going to go ahead and paste it. There it is. You don't have to do this part, but I just wanted to show you. The swivel foot didn't land in the same location, so this is probably an old file where this was mislocated. All right, so hopefully on yours it will work. If not, I'll accept whatever you can show me as far as your wireframe. Okay, so I want you to email me this section result file. Again, it saves it as a cat part, and it'll save a sketch for each item. So here is the clamp strap. Next one is the hex nut. Next one is the swivel foot shaft, the threaded shaft. Next one is just the swivel foot by itself, and so on. The hook, the knob, and so on. Okay, so it has a sketch for each item, and it's non-smart geometry. It's just a bunch of lines, non-smart. All right, so go ahead and send me this file also with your other parts of this assignment. Okay, so let's go back to the lecture and let's finish this off. Okay, so we did a volume cut. Okay, so once again, you're going to turn in a red line, clash analysis report, the XML file, and your section cut that we just did. Okay, just to review, send me your red line, your clash report, and your section cut. If I go back to my assembly, I can always see the red lines once again by double clicking on these 2D views. Change to aluminum, and my last red line, check the gap. Okay, so don't forget, send me your XML file, send me your section cut file, and send me your assembly with the red lines. Okay, end of lecture.